Yeah, shoot.
Alright. Hi everybody, I'm Darnell Dupuy, and today we're going to talk about the principle of turbocharging. So the purpose of a turbocharger is to force compressed air into an internal combustion engine cylinder, and this results in more power. This is helpful for smaller displacement engines, as you don't have to increase the displacement of these engines to make more power. You just essentially bolt on a part and it's going to increase more power. And this is more efficient because when you increase the size of engine bores, it tends to burn more fuel. So this is an alternative way to prevent burning more fuel by making more horsepower. So essentially, turbochargers work by taking unused exhaust gas and turning a turbine, and that takes air in through the other side of the turbocharger, and the air goes through an air intercooler and it goes back into the engine. So like I'll explain it from here. The exhaust gases leaves the engine and it spins this shaft on the turbocharger on the hot side, and it essentially turns the other side, which is the cold side, and that ambient air comes in the engine. And that goes through the intercooler, which increases the density of the air, and it goes back into the engine, resulting in more horsepower. So yes, this increases more horsepower by making more air, and that increases the air to fuel ratio. And that equation is done by the outlet pressure over the atmospheric pressure equals 1 plus efficiency times the pressure at the inlet of the turbine over P1 minus 1 to the specific heat square root of. So there are 4 types of turbochargers. There is twin turbo, single turbo, twin scroll, and variable scrolling turbo. They all follow the same airflow rate, and that's just volumetrical flow rate times air density. Oh, and this is just another example of a turbocharger. This is just the turbo itself. You got the exhaust inlet going in there and turning the other shaft, and that's going to take in air on the other side. So a single turbocharger consists of the most cost-effective way to have a turbocharger, and it is still efficient for smaller engines, but it has the disadvantages of only having a small range on the RPM, and it is not as responsive as the other turbocharger systems. These are actually more capable of producing more horsepower, but you don't get that horsepower instantly like the other types of turbochargers. You get turbo lag with the single turbo. Another type of turbo is the twin turbocharger. This has the advantage of being much more responsive compared to a single turbo, and it has a more consistent torque curve. So essentially meaning that throughout your entire RPM range, you will have consistent power throughout the whole time because you don't have that turbo lag. But with twin turbos, it is normally more it costs more to produce and is more complex to put together. So you have a more difficult time installing a twin turbo system on your car or whatever engine you're using. Another type of turbocharger is twin scroll turbocharger, and this makes it a twin scroll. You have like a covering on the outlet, and that the reason it makes it more efficient is because you have certain cylinders assigned to one side of that outlet, if that makes sense. So this helps the efficiency because when you have, how can I explain this? When you have an internal combustion and you have 2 cylinders going, the exhaust gas is going on one side, and then you have another set of cylinders going on another side, that prevents a lot of air overlap, and when you stop that air overlap, that creates more horsepower because you have more force going inside that turbocharger. So you have essentially more force going inside the engine as far as air. But the disadvantages of this is that it costs more, just like the twin turbo setup, and it's more complex again. Oh, and also you can only do it with certain layouts. You can't have a 5-cylinder engine with a twin scroll because you have to offset it with the same amount of cylinders. You have to have like 3 and 3 or 2 and 2 cylinder per scroll on the turbocharger. Another kind of turbocharger is a variable geometry turbocharger. This is normally used in diesels, and actually the surface area in a turbocharger, it actually varies. So like at high RPM it'll spread out, and at low RPM it'll stay kind of flat. But this is not that convenient for gas applications because it requires exotic materials, which makes it a more expensive process. And like I said, it's only seen on diesel trucks and things of that nature. You can determine the turbocharger size by calculating the mass flow rate of the turbocharger, and also other factors includes the boost pressure, performance goals, and the displacement of the engine. And that's how you determine what size turbocharger you will put on your car. And when you're designing a turbocharger, you have to follow this chart, and it's the corrected airflow versus the pressure ratio. And you always want to get it in this middle circle right here. It's called the island of efficiency. Another essential part of turbocharging is intercooling, and this is because the intercooler takes that air that you take in from the outside, the ambient air, and it cools it down. That essentially increases the air density. And when you increase the air density, you're allowed to force more air into the engine because more dense air, you can fit more in a certain volume. And that the intercooler has its own equation. That's the intercooler effectiveness equation, which is T1 minus T2 over T1 minus T initial. And the future of turbocharging consists of the use of electric turbocharging, and that is currently in development right now. I know Mercedes is currently designing an electric turbocharger. And this helps at low RPM as it doesn't have to take in exhaust gases at low RPM, because at low RPM you're not producing as much exhaust gases as you would at high RPM. So this works by using an electric motor turning the shaft instead of using that exhaust gas. And this eliminates the turbo lag that you'll get from that single turbocharger, and is very fuel efficient because you're not using any load on the engine to create that spin on the shaft, and it increases power at low RPMs. In conclusion, turbochargers are an effective way to produce more power on an internal combustion engine without having to increase the bore or the size of the engine itself. And like I said, it takes away the exhaust gases and it transitions it into more power, which is a very efficient way to produce more power in the engine. And for future internal combustion engines, we'll see them more in the future because today, most cars are actually turbocharged that come from the factory, especially high performance cars, because it's just a very efficient way to produce more power and torque. And yeah, we'll be seeing them in the future, especially electric turbochargers now.